There's one particular interesting aspect of properties in Kotlin, and that is the ability to delegate the behavior of the properties. Sounds a bit complicated, so let me give you an example. I'm actually going to cut and paste something that I've got somewhere. So here is a magical class that I've just copied, and it uses Kotlin.reflect, by the way, so that's a hint as to what's going on. Now what I'm going to do is I'm going to make your typical class called person. Class person, we're going to have var name of type string, and somewhere down the line I'm going to instantiate this class, so I'm going to have var p equals person, and I'll set the name to my name. There we go. Okay, and I'll also do a get as well, so I say val s equals p.name. Right, so so far, yeah, we have to provide an initializer, but I'm not going to. Instead, I'm going to do something completely different. I'm going to say that the implementation of this entire property called name is actually controlled by this special class. And the way you do it is you say by, and then you instantiate this class. So you say delegate, and don't forget the round brackets here. So essentially what's happening right now is that instead of the default assignments and acquirements of the value of this property, what's happening is a different situation. Instead, we're using this class called delegate, and we're using its get value and set value functions. Now these functions, they are predefined, so their interface is predefined. They basically take a reference to a actual property, and they have the property name, for example, and you can also set the value. So here would be the argument for the values. So the end result, when you say something like p.name, essentially you're not just setting a backing field, it's a more complicated operation. What's happening is somebody is calling, so you have an instance of delegate, and on this instance somebody is essentially calling set value, providing a reference to the property, some information about it, as well as the new value. So let's run this and let's see what we get. Alright, so as you can see, what's happening is when we perform the assignment, we actually assign by calling set value. So it says Dimitri has been assigned to, and then it tries to print the actual property. It does not have a pretty print of any kind. It's just a typical Kotlin output with some part of the pointer or something. We don't get the setter, unfortunately. I should have really done something like this, because otherwise it gets removed by the compiler for not being relevant, not being useful. So here we go with the getter. Thank you for delegating name to me. So once again, this is a handler for getting the property. Now you might be wondering, well, why on earth are we doing all of this? What's the point of having, what's the point of overriding the behavior of the properties in separate classes, as opposed to just adding the getters and setters right below the property? And the answer to that is that sometimes you want common functionality for all your properties, or all your properties. You want some sort of behavior. One example of such a behavior is lazy initialization, and for that Kotlin provides a built-in kind of delegation. So let's have some lazy value of type string, and it's going to be delegated by this type called lazy. So lazy, as you can see, it's a special construct, and you have to provide it a function. You can see the curly braces here. So you provide a function which is called on lazy initialization. So when you want to lazy initialize the property, you can do something, whatever it is that we do. So in this case, I'm just going to say lazy value initialized. That would be our lazy initialization, and then we can return the actual value, such as test, for example. So let's take a look at how this would actually work if I print line p.lazyValue, and furthermore, I'll do it a couple of times so that we can see that the initialization only happens the first time round. Now let's run this. And as you can see, the first time we executed, we actually initialized the value lazily, and then on subsequent call, we no longer perform the initialization. So that's one example of why you would want to delegate the behavior of a property as lazy initialization. Now let's take a look at a more complicated example. Quite often in your code, you want to be notified when somebody changes a property. And you can certainly do it manually, but you can also specify a more general approach to the whole thing. So for example, let's have other name. And it's also going to be a string, and this time I'm going to delegate it by delegates.observable. I think we need an import for this one. Yep. All right, so this is once again something that's available in Kotlin Properties Delegates. And now what we need to do is we need to have some sort of code which actually handles the fact that the property is being changed. So it's a lambda which takes the property, the old value and the new value, and here you can do virtually anything. So you can, for example, change the user interface, you can notify, put the thing on some sort of event bus, whatever. So in my case, I'm just going to print line that we have some old value being changed to some new value. And yes, you do have to provide it an initial value as well. So for that, I'll choose John, for example, and then we get to see how it actually changes as you change the value. So I'll have p.other name equals Jack, and then p.other name equals Jill. And let's run this to see what we get. Okay, so slight problem here. It should be a var and not a val. Let's try this again. All right, so as you can see, John changes to Jack and Jack changes to Jill. And the reason why this output is possible is because we essentially replaced the behavior of this property by using delegates.observable, which also lets us define a lambda which handles the change of the property.